basically, this is what we're going to do tonight. A little bit of introduction, understand the difference between decks and balconies, because sometimes people get confused on that. I hear people all the time calling balconies decks and decks, who knows what. A little bit about the codes then and now, just a touch of California specific stuff. This happened in California. So there was a big push to change our building codes here locally. And some of that stuff is filtered up into the I codes, which means it will, if it hasn't already, filter down into most of your areas that you inspect in, because almost everybody, but not everybody uses the I codes as their model code, the sort of basis that their codes are built on. A real quick taste of what San Francisco and city of Berkeley have done specifically, because they acted a little sooner than the state did. Then we're going to take a look at kind of what happens when things go wrong. The balcony collapse that Hollis had alluded to, that was the Library Gardens balcony collapse in Berkeley. I also have some information on a Sacramento apartment complex, another one in San Leandro, and and the bottom line is this is a national problem. It's not limited to California or San Francisco or Berkeley. We build stuff pretty much the same way everywhere. And so you are looking every day when you go out and you look at an apartment building or a condo complex, a lot of townhouses, they've got the same problems. You just may not have it tuned in on your radar, and then hopefully at the end we'll have a little room for some questions. So I have a class that I do on decks, and this is actually a slide I took from that. It's a gentleman that used to run the wood materials and engineering lab at Washington State. He maintains the deck failures, and I think you can use balconies and elevated stairs and walkways and in lieu of decks account for more personal injuries than basically anything else except for hurricanes and tornadoes. Unfortunately, Don died, so I can't ask him where he got that information from, but at this point, I just have to take it on faith. Primarily tonight, we're going to look at the International Building Codes, the IBC. They're in California, we've actually adopted changes to our residential code as well. That is not, as best I could tell, not filtered into the current IRC yet. I say yet because I think it's a matter of time. This session, if anybody out there has ICC credentials, certifications, email me afterwards. This is a preferred provider course. It's approved through ICC, and if you want to renew your ICC certs, then you need a certain number of preferred provider credits. This qualifies for 1.5 units. If you just need ASHI or some other organization, don't worry about it. Doesn't mean anything to you. So here's just an example. This is actually Library Gardens. I took it off Google Street, and that's what it looked like after on June 16th, 2:15 at roughly almost 2 o'clock in the morning. This balcony just flipped like a door. It actually hinged right down. And when it did that, it dumped everybody on the balcony down 4 stories onto cement. So needless to say, that did not end well. As Hollis made note, 6 deaths initially, 7 serious injuries, one of which was a paraplegic. So this is nothing to disregard. So what's a deck and a balcony? What's the difference? There's not really a really good definitions in the building code. If we go back to the 97 Uniform Building Code, which I don't believe was adopted in any place out on the East Coast, balcony exterior projecting system, basically it's supported by the building entirely, no independent supports. And if we look at a deck, it's an exterior floor system supported on at least 1 or 2 sides by the adjoining structure, and then posts and piers or other kind of supporting means on the other side. In the 2006 IBC, there was actually a definition, and that went away after the 2006, so you won't find that in the 9 or 12 or anything subsequent. But basically, on your left, that's a deck, and on the right, that's a balcony. So in California, at least, we've started calling these things exterior elevated elements, of which a balcony is one example of that, but also it includes and encompasses elevated stairways, elevated walkways, fire escapes in some cases. Basically, if it's elevated, exposed to the weather, and predominantly uses wood for structure, then we're concerned about it. Although in some cases, metal, like a metal uh, fire escape or something, that can qualify, at least in California, because we're concerned about the bolts that connect it to the structure. Um, so for all codes, regardless, balconies have always been considered part of the exterior wall cladding system. So any requirements that apply to the exterior apply to a balcony. Unfortunately, jurisdictional interpretation enforcement seems to be inconsistent is a nice word for it. And in many cases, non-existent, I think is probably a better word. So if we start going back in time and look at some of the IBC requirements, I started back in 2006 and kind of ran up. Basically, the exterior section, which is chapter 14, it includes, if you see at the bottom, balconies and similar projections, and then bay and oriel windows. Everybody always wants to know what's an oriel window. That's what they are. So what we call a bay window in San Francisco, I don't know what you would call them out in Boston or whatnot, but I'm sure they got similar stuff in older parts of town. So in the 2006, this is the requirement. The exterior wall envelope has to be designed and constructed in such a manner to prevent water from entering the assembly and provide a water resistant barrier behind the assembly, the veneer, and a means to drain the water should water get in, and then also to protect the wall assembly from condensation forming in accordance. In the case of the IBC, it's the International Energy Conservation Code. In different states, I mean, you go to Michigan, they've got their own energy code. California absolutely has its own energy code, and I'm sure some other places do as well. So typically that's going to be modified in the local area that you're in to accommodate whatever energy code, if any, that they've adopted. The other thing that actually becomes a kind of a big deal is how do we install stucco? Because a lot of these, the problems with them are that they're stucco assemblies, at least in a vast majority of them. But anything that's enclosed, but specifically stucco in this case, has to comply with these two ASTM standards, and that'll be important for reasons that we'll look at in a little bit here. Again, same thing in the 2009. If we look, scope is the same, and it says down in 1403, provisions of this section apply to all exterior walls, wall coverings, and components thereof, meaning these exterior elevated elements. And then, and again, in the 2009, has to prevent water accumulation within the wall, a means to drain, and also eliminate condensation, which I cut off on that one. And again, back to the ASTM standards. So the reason I'm kind of beating you up with this a little bit is simply to make the point that these requirements are not new. They've been around for a long time. If I wanted to go back further, I could, but I didn't feel like messing around trying to find out whatever code Virginia had adopted in 1980. So I just stuck with the low-hanging fruit and stayed with the International Building Code. Again, same thing. Stop water from getting in. If water gets in, drain it, and if you have to prevent condensation from occurring. And again, back again, and this is this is 12 years old, but there's states that are still on this. Stucco has to be installed in accordance with these two particular ASTM standards. Again, 15. I know this is redundant, but again, my point is not new. Same stuff. Three elements have been in place for decades, literally. Prevent water from entering. If it does, drain it, and don't let condensation occur. Here we're up to the 21. Same thing. I didn't go any further than the 21 because even though in theory the 24 is out, I don't believe a lot of people have adopted yet. But it's not going to say anything differently. So same three elements apply, same stucco provisions apply. The bottom line is this: exterior wall and cladding has to be designed and constructed in a manner that prevents water from accumulating within the assembly. It has to have a means to drain it should it actually find its way in, and you have to prevent condensation. Here's where the ASTM standards come in, because if you've, like in the case, the photo that we showed right up front, the keen-eyed version, people out there might have noticed that the bottom side of that Berkeley balcony had no ventilation in it. So one of the things that the ASTM standard has required for, again, decades is that where you have a horizontal to vertical joint, there has to be a casing bead or some means at the intersection providing a drip edge so that if water gets in there, there's a way for it to get out. In many cases, jurisdictions will accept strip vents. So the little, whatever they are, 2-inch by the width of the assembly vents that you see on the bottom of a lot of these elevated elements, that will suffice, because what you're doing is you're letting air get in. So if it gets wet, there's a way for it to dry. And if water gets in, there's a way for water to drain out. And that, literally, the absence of that killed 7 people and seriously injured a bunch of others. And that, if you think about what that would have cost to do right at the point of construction, it's nothing. I can tell you what it costs because they didn't do it. It cost 7 people their lives, 6 injuries, and roughly $45 million in judgments against the property owner, the property manager, the company that did the property condition assessment on transfer, and the contractors and architects and anybody else that they could get money out of, they did. So think about that for a second the next time you're looking at one of these things. So that's the casing bead. That's a code check illustration, but a little bit older one. But basically, that's a place where, and I know I don't have a pointer that I can use on here, but basically that casing bead is set up so that if water did get behind the paper before it ponded, it's going to find a way to get out of that assembly and drip out. And that's literally all it would have taken to keep us from killing those kids. So in the 21 International Building Code, we now have a provision, and this is in 2304-1225, that weather exposed surfaces, that's the exterior elevated elements, shall be provided with openings that provide a net free cross ventilation area not less than 1 to 150. So 1 square foot for every 150 square feet in each separate space. Really important. So begs the question, where did they get 1 to 150 from? Well, if you know, it sounds really familiar to what you see for attic ventilation, for ventilated attics, and the same thing for crawl spaces. If anybody out there builds air ventilated crawl spaces, I know a lot of jurisdictions have moved away from that because The conditioned ones are a lot more energy efficient in a number of especially colder climate zones. But anyway, the point being here is that there was no research. There was They just simply said, well, it's good enough for attics and crawl spaces, so it must be okay for this. And I'm going to let you in for a little bit of a code secret, and that's this: if it ends in a 0 or a 5 in the building code, they made it up. So there is no research that says that 1 to 150 is any better than 1 to 198. That's just a number that's evolved over time. And so we don't really know. I can tell you this, when we look at how that translates into ventilation in a enclosed space, it's actually not very much. And I think you can easily make the case it's probably not enough, but that's the number that's in the building code. So you should, on newer constructed stuff or anything that's repaired in larger properties where they're not falling under the residential code, you should, if you've adopted, and I say if you've adopted locally, the I codes and the International Building Code is your model code, and they haven't edited this out, you should see ventilation underneath all of your balconies. I think you can make a really strong case that it was never not required, because how do you prevent moisture from entering, allow it to drain, and prevent condensation in a balcony or elevated walkway or enclosed stairway? How do you accomplish those three things without putting vents on the bottom side? I got I've got free beer at the next IW for anybody that can answer that question for me. I can tell you this: the lack of the defendants being able to answer it in trial cost them $45 million, roughly, give or take a little bit. So another new requirement in the 21 IBC is that if you have an elevated balcony or walking surface that's weather exposed and where there's structural framing and there's an impervious barrier, so there's a moisture barrier over the top of the wood framing, that it has to have a special inspection. So it cannot be concealed until a jurisdictional inspector or somebody that they've approved of has looked at it and said, yeah, this is okay. And here's one of the problems with this is, if you look in the places that certify special inspectors, I'm talking about, when I say special, I mean the people that go in and do rebar cages and drilled piers and certain types of concrete inspections and whatnot. The people that certify those, there is no elevated elements, water barrier special inspection. So it kind of falls to either the jurisdiction to do it, or what we're seeing around here is they push it off to the manufacturer of the material, and they'll use like a field sales rep to come out and say, yeah, our product is installed in accordance with the manufacturer's instructions. And the jurisdictions, at least in the area I play in, which is the San Francisco Bay Area, they're accepting that. But this part hasn't really been figured out yet. And unfortunately, I would argue that these new regulations don't actually keep Berkeley from happening again. Another big change is that balconies and decks, the live load requirements are now 1.5 times the area served. So as an example, if the interior space had a 40 pound per square foot live load requirement for its structural characteristics, then 60 would be required for the deck or the balcony. But no matter what it is, the balcony or the deck doesn't have to exceed 100 pounds per square foot in terms of its ability to withstand and a live load. So the bottom line is this: we have to make things watertight. They shouldn't leak. If it leaks, we have to make sure the water can drain to the exterior. We have to prevent condensation. Waterproof surfaces need to drain, and there's specific requirements now to ventilate. And we have to inspect waterproofing before we can seal. And so an example of that would be in the case that in Berkeley that was a wood framed assembly that stuck out of the side at unit 405. It had a waterproof membrane over the top of what should have been plywood, but was actually OSB, and then a 2-inch or so lightweight concrete pad over the top of that. So pretty typical construction. But that's what this was sort of geared around, is that type of construction. The same thing would apply though if they were using some kind of a epoxy or polymer coating over the top. That would have to be inspected as well. In my opinion, what is missing, and I actually had a chance to input before they finalized the state legislation on this in California, they should have required pressure treated lumber regardless of whether there's a waterproofing system above, because to not do that assumes it's not going to leak. And I think, as we all probably know, assumptions can be bad, and it turned out really badly for these Irish kids. And also, so you inspected the waterproof membrane. What happens now? Well, they close it up. So in the case of a lot of this stuff where they're putting a concrete pad down, what does that mean? That means they staple down some wire, and people walk on it and mess around with it, and then they pour concrete. So all the staples punch holes in the waterproof membrane. So there's a bunch of opportunities. And then in the case they did it at Berkeley, they come out with a metal guardrail assembly or guard assembly, and they drill and put 2-inch screws through the concrete into the wood below. So around the perimeter, they just punched a whole bunch of holes in it. And guess what? It leaked at all those places. I always like Joe Stiebrick, who, if you've never seen him talk, you should run, not walk to the nearest Stiebrick talk. He's the king of building science in the US and Canada. And he always says water happens, sort of like brown gooey stuff happens. Water happens, so you just have to assume it will and plan for it. Back to the why we should have pressure treated lumber in these cantilevered assemblies. But the building trades apparently lobbied against that. I think that's probably the most logical reason that didn't happen, because it would have been an easy change. And if that had happened and they'd ventilated it in Berkeley, we wouldn't have these dead people. That would be my assumption anyway, or my position on it. So an important thing to understand is that something doesn't have to leak to rot. And that, in fact, is a big part of what caused the failure at Berkeley. And that's, to my point tonight, why building science matters on this. So in general, the 101 version of this is heat moves from hot to cold, and pressure moves from high to low. So if you can just keep that in mind, you now understand more than almost any architect and contractor and building official on the planet. And then the question is, how is that impacting the structure? Prevailing winds also impact heavily building performance. And I don't just mean like when a hurricane or a tornado comes through. That certainly can radically alter the way the building performs. But I'm talking about in the way the building moves air and moves heat around inside and out, inside to outside. So the windward side of the building, the side with prevailing wind, tends to have a higher air pressure relative to the interior, and just the opposite on the leeward side. You get negative air pressure relative to the interior. Pressure differentials move moisture through the exterior wall cavity. In the case of the pressurized side, it's going to push moisture into the assembly. In the case of the leeward side, or the side opposite the prevailing winds, air from the interior of the building is going to be pulled into the exterior and towards the exterior rather, and that's going to move moisture and air in ways that weren't necessarily ideal. That's the reason why we want to try to prevent condensation. I mean, it's literally, and I had a building, I'm trying to think when it was, probably a year and a half ago, where literally it was on the coast, and you were getting what appeared to be water on the prevailing wind side actually going uphill through the cladding. So around windows, the pressure differentials were high enough that air from the inside, because it was such a low pressure, was actually sucking air around the window frames and up and over the paper and the flashing at the joints. So air movement can be a really powerful impact on the building. And again, leeward side, kind of just the opposite. You can actually have moisture be drawn, and air being drawn from inside and pushed to the outside. And those forces are pretty strong. So if something is just lapped, that won't stop air movement. It has to be, that's why you're seeing this move to things like zip-R and whatnot, where they're taping and sealing joints so it becomes a really airtight joint wherever you connect things on the outside, and that water resistant barrier. That's why it's so important that we get these buildings so that we eliminate unnecessary air movement through the wall and floor and ceiling assemblies. So just to look at this in a pictorial version. So if you have air moving from the left of your screen to the right, that area on the left side exterior of the building is actually going to be a positive pressure relative to inside. And then air on the exterior and also a little bit at the top will tend to have a negative air pressure zone. That's the kind of pinkish magenta negative signs. And that's how air gets pushed up into attics and out. And that's how in the case of Berkeley, as we'll see, that situation on the right is what literally contributed heavily to these kids dying. Additionally, you get the stack effect, which I don't know how much the people here know or don't know about this, but basically warm air rises, which is not a real shocker, I think, to most of us. But here's what that means. If you look only at air movement due to heat rising, it means that the top of a multi-story building is going to tend to be pressurized, and a positive pressure, versus the bottom, which will be a lower pressure, and that's simply air rising and pushing up against the top of the building. And in the middle, there's going to be this neutral pressure plane. That's the point, and that's not going to be necessarily at the middle of the building. That's going to be wherever the magic place is for that building, based on the amount of air leakage in all of those exterior openings. So it might be lower, might be higher, depending. But that point will be equal on the inside and the outside. But anything below that point will be more and more negative. As you go towards the bottom, it'll get increasingly more negative. And as you go towards the top, it becomes increasingly more positive pressure. And this is actually a Building Science Corp diagram, which is Joe Stiebrick's company. If you don't know who he is, Google Building Science Corp. They're in Boston. This guy is absolutely flippin' brilliant. And he also speaks English. And he also has a pretty wicked sense of humor, too. So make sure you don't get offended by politically incorrect statements if you go to see him live, because he can embarrass drunken sailors, I think, on a good day. But anyway, he knows his stuff. That's basically, this diagram is saying the same thing as the previous one. It's just a Joe approved version of the diagram. So we're going to get to an example of kind of what happened in Berkeley. So if you take the square on the left of your screen and assume that is the interior of the building that had the balcony collapse, and what sticks out, that's the cantilevered area. That cantilevered area was not insulated or air sealed. So there was nothing other than just blocking and whatnot at the exterior wall line. There's nothing to prevent air movement. So as warm air rose in the building, and I say warm air, I mean just the regular conditioned air in the building, as that rose and it hit the floor, or at the what would have been the top of the floor of the fourth floor and the ceiling of the third floor. The fact that it was negative air pressure on that right outside area, because it was on the leeward side, pulled air into that balcony cavity. And what happens when you have warm air move against a cold surface? So think of all the windows you see where you get condensation on the windows in the winter. That's exactly what's happening there. You've got warm, damp air hitting a cold surface, and the moisture condenses out. And that's simply because the way the dew point works in the air and whatnot. And that's a little beyond what we're going to talk about tonight. But basically, the warm air will typically have a higher moisture content than the same air would have if it were cold, and all that moisture condenses out. Well, at 8+ years of occupancy, the building actually had finished construction in 2006. So technically, the building was 9 years old, but occupied wise, it started occupying January of 2007, and the catastrophic failure occurred in June 16th of 2015. So 8 years and some change of that going on was probably the single largest contributor to these kids dying. So here's an example of a joist bay. I just arbitrarily picked 8 feet and assumed 16 inches on center and 2x dimensional lumber. So that means we got a 14 3/8 by roughly 8 foot. Now the current code requires that 1 to 150, and it does say cross ventilation, which means there's 2 vents, not one, which you may see a lot of older stuff where it's got a single strip vent, or sometimes we'll use the round vents or whatnot. But now it has to have 2, and they have to be, so it provides cross ventilation. If we do the math on that, it means we need 2 vents that are 4.5 square inches each. So the point here is, it looks good on paper, that 1 to 150, but the reality is those yellow squares are how big in scale, or how big the vent openings actually have to be. It's not a lot of ventilation. I think you could probably make a good case that those kids probably still would not have died, because it would have given a place for some air to get in, and also any moisture that condensed out, and there probably was leakage going on as well that we'll get to in a little bit. But anyway, the point being is it probably would have still slowed it down to the point where that wouldn't have happened. But bottom line is, you can underventilate anything like this. You can't really overventilate it. And so more is better in this case. So I think you can make a good case that a strip vent would have been better, but in this case, that's what the code would have required. California passed 2 bills as a response, and this happened actually very quickly after the Berkeley collapse. It was sponsored by a local state senator it's my local senator here, and a state assembly person that's over in Berkeley. So we have an assembly and a senate in California. So we had one assembly person and one senator that sponsored, and that's how I knew him, because I would go to his legislative public hearing meetings and just meet and greet with him. So he knew me enough, and he knew what I did, that we actually talked a little bit about the legislation. The bottom line is this, kind of the Reader's Digest version. Um, the first one applied only to multifamily, 3 or more units, did not apply if it was a common interest development. So nothing with an HOA. Wood frame construction had to have the first inspection. We're coming up on that in January of 2025. Every 6 years thereafter, required that whoever inspected had to be licensed, state licensed, architect, civil or structural engineer, and a general contractor with what we call an A, B, or a C license. And if they're a GC, they had to have a 5-year minimum of building multi-unit light wood frame construction. So somebody doing kitchen remodels is not going to be able to inspect these. Somebody that builds multi-unit apartment buildings could. Um, the dangerous part about these inspections, not that you guys on the East Coast care, but literally whoever's inspecting them has to certify them as safe until the next inspection 6 years from then. So there's no way in the world, like Inspector Pro or any of the E&O guys for home inspectors, even if you did happen to be a licensed architect or engineer in California, there's no way your E&O insurance would cover you for that. They'd have a stroke if you turn in a claim on that, I think. The difference between that and the other bill was targeting HOAs specifically. Again, 3 or more units, wood frame, first inspection by January 1 of 2025, every 9 years thereafter. And that's because in California, 9 years was the periodic rate that they're required to do reserve studies on their HOA to determine condition and the financial wherewithal of the reserve study fund. And we only allow licensed architects and structural engineers to do those inspections. So big condo projects, that's what's going to be required there. San Francisco acted a little sooner. They have a little different set of rules. Actually, San Francisco enacted the original version in 2004, and then they modified it right after the collapse. But hotels, 6 or more, multifamily, 3 or more, they include specifically metal exterior elevated elements because they've got a lot of these old metal fire escapes and decorative balconies in San Francisco, and they've had collapses on those, so those are included. They've been requiring inspections in SF since 2004, and they're every 5 years. And then they allow not just architects and engineers and licensed contractors, but also what we call a structural pest control operator, which is somebody that's licensed in California to do termite inspections. So they allow termite inspectors as well. I know in a lot of states, the home inspectors do termite. Here, that's a licensed function, and there are a few people that do, but the license is actually pretty hard to get. So it's pretty rare to find somebody that's a home inspector that also has a structural pest license. Berkeley, also because it was literally in their backyard, 3 or more units. They included fire escapes and decorative balconies. First inspection for them was 2016. And then you were allowed to, if you had a big complex, you were allowed to stagger those in a cyclical basis up through 2022. And that's because they just recognize that some big condo complex, they're not going to be able to go in and inspect 100 balconies. So they gave them the ability to start with a random sampling, and then before March of 22, they had to have done all of them. And it's 6 years on 6 years on condos, 9 years on everything else, for whatever reason. And then they defined who could do the inspection. They also allowed a certified building inspector. By that, they meant somebody that had like ICC certifications. Condos, though, has to be a architect or engineer. And in California, those are both licensed, state licensed functions. So really quick, kind of what happens when and where things go wrong. Balconies, there's very little statistical evidence on failures and failure modes for balconies. So my assumption has always been that they're kind of lumped in, if you will, with what we see for stats on wood decks. Balconies are, I think, in large part more complicated. They usually have waterproof membranes. A lot of times they can be enclosed with little or no ventilation, lots of penetrations. And also, unlike as we saw with the definition, they're relying strictly on that section where they attach the building. That area is how they're supported. There is no plan B. There's no outside posts or girders or beams or anything. So most of the time, the guard penetrations and other penetrations rather are not properly waterproofed, and that was the case actually in Library Gardens. But that was a contributing factor, not the only one, as best we can tell. And so drain through design. So in other words, a cantilevered balcony that has just wood members sticking out and then space decking over the top where there's no waterproof membrane. The water just literally falls through and drains through. That's a common point of failure or cause for failure is the wood rot caused by water ponding on the top of those cantilever members. Guards almost 100% of the time or contribute in some way or another on failures. I think it's overall guardrail failures are about 10% of roughly 10% of deck failure, what's classified as a deck failure. By that, I mean people falling and getting hurt. The wood members on anything outside, that's the worst possible conditions. You've got, rain, snow, bugs, everything. A lot of these things are not constructed properly to start with. They're not waterproof properly to start with. If they were repaired, it's usually, and at least in my area, a lot of these things look like they were done um, by handyman, the repairs on some of these things. And until the current code cycle, there's been a lot of, not a lot of guidance in terms of what was required that was spelled out in plain English. I mean, I think, a big project, I have no sympathy for the contractor on Library Gardens because you know what, you're building 4-story podium style construction, light wood frame construct. You're playing with the big boys. You ought to know. You ought to be on your A game for doing something like that. I give no sympathy to somebody like that where somebody that's doing a one-off single family home. Maybe the person is doing their first home or something, and they need some guidance from the building department or an architect or something. But now we have it in black and white in the codes. So again, 6 killed immediately, 7 seriously injured. 1 was a paraplegic. 7th, as Hollis mentioned, died in 2023 as a result of the injuries. The waterproofing and the general contractor had a history of construction defect litigation, including one that was 26.5 million in settlement. The CSLB, that in California, that's the contractor state licensing board, who's the state organization that licenses general contractors. They had no knowledge of litigation because there was no requirement for a contractor to report back to them if they had a construction defect lawsuit. That subsequently has changed. So now the contractors have to report back. So you can actually go and look at a contractor and see not only have they, do they have a license? Is the license active? Do they have a bond and insurance? but do they have a history of litigation? Pretty useful information. Would have probably been really useful for the people that of the of the families that uh, had loved ones die. Um, so again, I know we keep repeating this, but construction finished roughly 2006. Certificate of occupancy issued January of 2007. The collapse occurred June 16th, 2015. That's literally 8 years from new construction to dead people on the pavement. Everybody assumes when they first heard about this that it was, a 50-year-old building or whatnot, and the answer is no. It did not take long. Um, and again, I don't know what you guys call it out there, but these a lot of these apartment buildings, condo buildings, they're an elevated slab with 4 stories of light wood frame above. We call that podium style. So the podium is that elevated slab, and then they go up from there with light wood frame construction. This is very typical construction for, I think, anywhere in the U.S. Wood frame. There was some PSL, LVL stuff, lots of OSB. Um, the balconies were supposed to be plywood, which probably would have bottomed sometime because, as we probably all know, OSB is like mold candy. Um, I think one of the guys, I'm trying to think what his name is now. He calls OSB vertical mulch, but basically OSB rots really quick. Um, but it was a wood framed assembly. The balcony at Library Gardens had a waterproof membrane, 2 inches of concrete, and metal guardrails that were adhered with roughly 2 inch vertical screws. So lots of opportunities for holes to be punched in the waterproof membrane. And like I said, pretty typical construction. So if you look, this is you're looking at the top one is unit 405 and then 305 down below. If you look down there, and this is Google Streets, what's not there is any kind of ventilation. There was zero. And that's what it looked like um, in 2015 when the collapse occurred. The thing rotated just like it was a door hinge, and literally dumped everybody down. I don't know if anybody actually ended up on the lower balcony. I don't think they did. I think pretty much everybody got flung onto the sidewalk, and the ones that survived, I can't imagine ever being the same. But yeah. And you see the black stuff up above. That's part of the waterproof membrane. Part of what happened too is the concrete and um, a lot of the debris ended up falling onto the street. So not only did people fall all the way down there, but then they had a bunch of random construction debris fall on top of them. So here's a couple pictures of them actually kind of deconstructing this thing once the next day hit, the next couple days actually. That's actually the stucco assembly. So you're looking at the bottom on that side where they're rigging that thing out. That's actually the balcony assembly, and what you see coming out of the wall, that's what was left of the cantilever assembly. Not much. And in fact, if you saw the slide a ways back, what was on that balcony down below the 305 balcony, that was little more than what amounts to like oatmeal. I mean, you could crumble this stuff with your hand. More of the same. It's pretty gruesome. Some of that was dimensional lumber, and we think there was some of it that actually was either LVL or PSL. There literally wasn't enough left to be able to tell. Unfortunately, I couldn't get over there quick enough to take photos. I do some stuff, or I'd used to do, I haven't done it in a while, with our local CBS affiliate here. And the next morning, I got a phone call from them asking questions about this. At that point, I was kind of their building code um, cat catastrophic event go-to guy. The reporter that I used to deal with is left, and the producer also is retired. So I don't see much from them anymore. But they were literally on the air on the phone before they went on air, trying to find out what low, because at that point no one knew whether this was an overload collapse or whatnot. And I'd already looked at the photos and determined that probably wasn't overloaded. It was simply had rotted out from water leakage or moisture or whatnot. Um, so the city of Berkeley, and I know a lot of East Coasters, you don't care about this. They issued a letter in June 23rd. So this is roughly 7 days after the collapse. And their analysis was that the building safety staff confirmed that the approved plans complied with the applicable California building code requirements in effect at that time, and that all state code mandated inspections were conducted. So, to put that in plain English, the attorney for the city wrote that. And if it were a book that was published and put on Amazon, it would be in the fiction section. The reality was it obviously leaked. It wasn't waterproof. They had no provision to drain the interior cavity. It wasn't ventilated. Condensation was allowed or possible for it to form rather. And you had 6 people die and another 7 seriously injured and another death later on. So I find this really upsetting personally because and I get the city doesn't have liability because they exempt themselves, but this is a case where the city inspectors should have said, no, you need ventilation, and they should not have allowed the OSB in lieu of the plywood, and they didn't. They didn't. And that's my humble opinion, and I made that abundantly clear to the plaintiffs' attorneys um, on that as well, that that was my feeling, even though there was no way for them to sue City of Berkeley. Oops, sorry, wrong way. So the bottom line is the balcony wasn't built correctly. And my question, and I actually posed this to my CBS local affiliate, what do you think they didn't do right also? I mean, because if they didn't do the balconies right, it's a pretty fair chance that they didn't know how to build other stuff right. And so I went over there shortly after the collapse. All this stuff was cleaned up, so I couldn't get pictures of any of the debris or anything. And sure enough, around a lot of the windows, it's hard to see on these photos, but those windows in the middle, if you look down below, there's all kinds of stains in the stucco that would indicate water coming out of there. This cantilevered assembly, if you zoom in on that, you got water stains coming out from behind cladding, water stains around that window, kind of in the middle. Um, Here's the same contractor, different project. This is actually just probably 10 minutes south of me. At the time I went by, which was roughly, I think I did this in July of 2015. This building, similar podium style construction, light wood frame, balconies on the front side. Everything was covered up because guess what? They were having to repair it because they'd already been sued. That was the $26.5 million settlement. And there's the other side of the building where the balconies also leaked. Now, bear in mind, they had a different contractor who was there to repair damage caused by construction defects. And somebody I know went in there after they finished, and all the new balconies were sloped to the building and away from the drains. So unbelievable, you know. And the city of Millbrae, I'm pretty sure, knew why they were doing the repairs because the balconies all leaked and you know, that water intrusion problems. And yet you've got balconies that are basically sloped to drain away from the drains towards the building where water will pond. Crazy. So some general signs of trouble. Here's a stucco cantilevered assembly, and there's all kinds of stains and cracks visible. You know, my counsel to you guys is don't take anything like that as no big deal or normal, because you don't know what's going on inside, and you'll see here pretty quick why that's a big deal. Waterproof membranes. This is a wood framed assembly with an epoxy over the top kind of deal. That waterproof membrane's damaged. Here's one where you've got a roof deck over, I think this is over a garage, but if you look really closely, down below that gutter running across there, there's stains and whatnot coming through there. On the inside of the garage, there were water stains below right where those stains were. If you get up close, there are drip marks coming from behind the trim and the gutters. I mean, how does that water get there? Something's leaking. Here's a cantilever drain through design, and hard to see, but somebody scabbed on 2x2 to repair, and I use that term loosely, those cantilever assembly members. Well, you can't like add lumber onto a 2x and expect it to have the same load bearing capacity. It just doesn't work that way. So pay attention to drain through assemblies, look for cantilevered or framing member deterioration on the bottom, flashing at that wall connection, cantilever top joist protection not required. But if you see where someone's put a membrane, either butyl or some kind of metal strip over the top of those cantilever joists, that's a sign of somebody that was at least trying. Improper repairs. We see a lot of scabbed wood around here. I have no idea what's going through people's minds, but you know, they take, you know, let's say you got a 2x10 coming out of there, and they'll cut out, notch out on the top side, and put a 2x4 in there. Well, that's not going to that looks nice, but it's not going to actually have any structural, you know, connect kind of reinforcement of that assembly. Rim joist connections are a big deal. Guardrails are a big deal. Waterproof coatings, poly coatings, those epoxy coatings, the manufacturers usually recommend recoating every 5 to 7. That's almost never done, but prolongs the life. In the case of Berkeley, we think, and we don't know because there was not literally enough left to tell, but we don't think they integrated the exterior door flashing correctly with a waterproofing assembly on that deck and balcony. Guardrail those are just automatic points of water entry almost. And guardrail failures, again, it's like almost 10% of collapses will occur at the guard connection where people are, you know, standing out there leaning on the guardrails and watching the world go by. A lack of drainage and ventilation in any kind of enclosed, soffitted area like these ones we've been looking at. The kind of statistics we have are really poor. The Consumer Product Safety Commission, literally the way they get their samples is they take statistics from 100 hospitals across the U.S. and then extrapolate that to the U.S. population. So if 15% of the population falls in the coverage zone of those 100 hospitals, then they simply multiply by, you know, 6 point something to come up with a number for the U.S. So those are, I would say, guesstimates is probably a kind word. Those are just the only numbers we have. And they do the same thing with electrical problems and fires and whatnot. Those numbers are not generated. I mean, if somebody tells you that there were 2,973 fire deaths last year in the US, that's not a meaningful number because they don't know. They simply extrapolated out of the data that they do have um, up to a national population level. And the other thing that they don't do in the CPSC numbers, they don't determine why the collapse occurred. So there's no determinate causes in any of this data. It's simply somebody on a deck got hurt. Um, there is one study, Michael Baudry, who's I don't know if he still is or not. He was the exec director at NADRA. He did a study, and his company was called Legacy Systems, uses CPSC data. It aggregates deck, balcony, porch, and similar stuff, and came up with 33,000 failures or collapses, 18,000, so not quite half, or a little bit more than half, rather, deemed to be serious. That's the data underlying his report. That's actually out of his report. One of the things I want to leave you with is when a collapse occurs on a deck, a balcony, a stair, 60 to 75% of people are going to be seriously injured or killed. And there's so many collapses that TV news doesn't usually report them unless it's like a bunch of Irish kids dying. That made the news, but the other stuff probably didn't rise to the level. So number of collapses per year and time of year matters. So you see summer months, it's higher into the early fall. And that makes complete sense because if the weather's nice, people tend to use the decks and balconies more. So an important thing to understand is that, and this holds true of decks as well, they rarely fail from wind or seismic loads alone. It's almost always the result of live loads on something that's improperly constructed or damaged. So if you think about it, the live loads on these, when you look at that chart and it says, 60 pounds per square foot or whatever, they assume uniform loading. They assume people are standing at evenly spaced increments all over that surface. That's not the way that a deck or a balcony gets loaded. It gets loaded by people standing on the outside edge and leaning against the guardrail. The overloading itself, in the case of Berkeley, absolutely was not the case. If that thing had not been damaged, no one would have died. But the reality is, whether it's a deck or a balcony, people are almost always present. So the people sort of become the proverbial straw that breaks the camel's back. And here's a case in point. This literally is somebody took two pictures of this party. I think it was a senior party for a bunch of kids. That's obviously a deck, but they took picture one and picture two as they're on their way down. So it was obviously in bad shape beforehand, but having all these kids on it simply caused what should have been a really special day for a bunch of high school seniors to turn out badly. So if we look at library gardens, the first indication of a problem occurred about a year and a half, almost 2 years after the thing was actually built. So what you see on the right, that photo, that's a 6-inch diameter mushroom growing out of the balcony at 405. The tenant took a picture, sent it to building maintenance and said, there's a mushroom growing out of my balcony. What's up? And so we don't know for sure, but it went into the building's maintenance system. They had a computer log. And then shortly thereafter, it disappeared with no indication that there had been any action. So what we think they did is they kicked the mushroom off or knocked it off instead of, they obviously didn't know enough to know that a stucco with a concrete pad, you don't have mushrooms growing or fungi, whatever it is, growing out of that, unless there's something really bad going on. So somebody happened to literally a week before the collapse, just take a picture of you look in the back, what you're looking at is fog rolling in over the Golden Gate. Somebody took a picture from their balcony, um, literally days before this occurred. And if we zoom in a little bit, notice this thing was already leaning. That's a scary thought. So that thing was already in failure mode a week before. It had been in failure mode for probably years, but it was collapsing under its own weight a week before these kids died, and no one picked up on it. So we're actually going to look at some forensic photos. One of the things I didn't talk about is I got called by the attorneys for the plaintiff that represented 45 family members. We didn't have one family person. I think that was the paraplegic, but anybody that died or was seriously injured was on the case. So I went in, basically, they wanted somebody to look at the property condition assessment, the inspection, and say, was this done to a reasonable standard of care? And what I kind of realized quickly is they didn't really understand why it had failed. They were thinking water, and it was. I mean, it was water, but it wasn't water from leakage. Predominantly, it was this ventilation problem. And so my role kind of expanded to some of the forensic analysis of this stuff and helping them work through that. But this is actually the balcony assembly when it was taken to a warehouse and they started to pull it apart and try to figure out the kind of what happened. And that's it upside down. So you're looking at the guardrails and what you see at the back, that's what's left of the waterproof membrane and OSB and the like. It had a drain hole towards the top and signs of water coming out. Now, bear in mind, that's actually above the bottom is at the very bottom of that assembly, and the top 2 inches is concrete, and that's further down. That's like right at the waterproof membrane or below, and you had signs of long-term water moisture coming out of there. That one was plugged with what looked like biologic matter, so like fungus and whatnot. More fungus coming out of the assembly right at the joint between the wood and the concrete. That's actually what was left of some of the OSB. More concrete on the bottom going upwards. That's what was left of the decking. More of what's left of the framing and the decking.
10
You're
minute,
look
10-minute warning, Skip.
Okay. We should be there pretty quick. Um, that bottom part, that's the concrete, and then what's left of the one of the cantilever joists. More what's left of a cantilever joist. And so it was away from that. That was unit 405 was on the leeward side and at the top. So it was away from most storms. We were in the middle of a epic drought here. So there was almost no rain occurring. And yet the whole thing rotted out. I would maintain to you guys that this is a national problem. It's not, Library Gardens is not some isolated case. Here's an apartment complex in Folsom, which is near Sacramento, out in the valley. It's very dry out there. It's kind of almost semi-arid, but this is a very common type of installation. Concrete stairs with a metal, post underneath it. What you're looking at, that was the stair that went to the floor above. So that's what was left of it. That's where the stair attached. It's one of these kind of stairs. That thing fell. Now, when it fell, there happened to be some poor kid walking underneath it on the ground. So the stair assembly came down on top of him and killed him. Um, Here's an apartment complex in San Leandro, also in the Bay Area, 1960s construction, wood, stucco, no ventilation, concrete pads. The only gives or the only tells were some damage around the guardrail penetrations and no galvanized sheet metal flashing at the wall connection. And when they opened it up, it was gone. I mean, that's what's left of the framing underneath there. Um, the cities, at least where I'm at, do not, even after we had this horrific event, don't enforce the codes. So this was repaired 6 months before I was there. Now, they pulled off the guardrails. They pulled off the stairs. They stripped the stucco on the bottom side. They redid the membrane on top, which was epoxy over plywood, and then they didn't ventilate it when they put it back together. And they also allowed them to put the guardrails back on. In California, we require 42-inch guards on new construction of this type, and they let them put the old. Um, I'm not even sure they were 36. They were pretty old. They might have been less, but this right here, the building owner thought they did the right thing. They hired a licensed contractor. They got a permit. It was signed off. It was done in early 2019. The repairs were completed. The codes at that time required cross ventilation, signed off by the city with no vents. They reused old stairs and guards, which were non-conforming. All that did was tee it up to have another Berkeley happen. Um, Again, 8 years old, 2 years to the first sign of trouble. It was on the top floor, leeward side. There were 4 balconies total. That was the worst one. I don't think it's a coincidence that it was where it was. We were in the middle of an epic drought, so probably some water intrusion, but it had to be predominantly at the absence of ventilation. So national issue. Many of these elevated elements that we look at, and I say we collectively, they're beyond their service life. They were, if you're lucky, they were built okay for the time, but a lot of them improperly constructed, improperly repaired, or both. And remember, when somebody falls off one of those things, when it collapses, roughly 2/3 are going to be seriously injured or killed. So take them seriously. You got any questions, feel free to reach out. I mean, I'm happy to talk.
So we did
Hey,
have one question from Velma. Apparently, she had some. She's somewhat familiar with this case, and was talking about potential for uh, fasteners penetrating the waterproof membrane.
mm,
Is that
absolutely, but again, we were in an epic drought. So there, when I say epic, I mean we had almost all of our reservoirs in California were at historic lows. We'd had so little rain and snow, so we weren't getting any water, not from the sky. Um, Normally that area gets maybe Bay Area. I'd have to look. I don't want to guess, but it's not a really. This is not a tropical rain environment we're talking about, but it's also not Arizona. So even in a normal year, there probably would not have been enough water to cause that alone. The only thing that we could conclude was that the lack of ventilation caused the problem because it was it checked all the boxes. It was on the low pressure side. It was the high point. There was no air sealing done between the living space and um, the cantilever balcony, and so and the devastation in there. I mean, I can't emphasize enough. There was like nothing left, and we're talking about multiple two by whatever they were, 2x12s or 2x10s. They were just there was you could pick that up with a vacuum cleaner, most of it.
so? I think Larry had a question. Larry, Sarah, you want to go ahead, Larry? He's trying to
So
unmute. He's probably muted.
so anyway, I kind of fell into this as an expert witness case, But I actually, I mean, I don't say this lightly. I think actually I was the one that gave him the pieces of the puzzle because this was BlackRock was the property owner. They're the largest manager and owner of residential property in the United States and Canada, I believe, well over 100,000 units. And when they interviewed me for the position for the expert witness case, they said the the plaintiffs are not going to settle, or the defendants rather are not going to settle. They already told us they don't want case law on this. They're going to the mat. I came in like early September, and there was a couple things that I think I brought to the table. One was this building science approach to the failure, and the other is some California specific stuff in terms of landlord responsibility. And the reality is, in December, after 10 days of negotiations, they settled for in excess of $40 million. I don't know the exact number, but I think it was around 42 to 45. Um, and BlackRock could have fought that for until the cows came home because they had as much money as they wanted to throw at it. They just they took it their lumps, and because they knew they had no place to go. The people that did the PCA, the property condition assessment, made no mention of there being no ventilation in that balcony, or those balconies, plural. There was none in any of them. And so they settled out. The contractor settled out. The waterproofing contractor settled out. The architect settled out. And eventually the property owner and the property management company, which were both BlackRock, they were just different buckets of the company. They both settled for the biggest numbers. So anyway, my hope for you guys is that you never get on the wrong side of one of these, but just take them um, and take them seriously.